Hey everyone, welcome back to Swift Fundamentals. Today we're diving into arrays and collections in Swift, focusing on arrays and briefly introducing dictionaries and sets. Collections allow us to store multiple values, making it easy to organize and manipulate data. Let's go ahead and dive on in. So I'm going to create a new playground on Xcode, but if you want to follow along in the Playground app or incorporate any of these elements into a personal app of yours, feel free to do so. And I'm just going to go ahead and call mine arrays playground. I'm going to open up my console in the bottom right corner here, and I'm also going to click and hold on the play button to automatically run my playgrounds. So arrays are the most common collection type. They store ordered lists, meaning items stay in the order that you add them. So let's go ahead and create an array of usernames and explore ways to add, remove, and modify items in the array. So what we can do is we can declare a variable here, and we'll say usernames equals, and then when you want to put items in an array, you're actually going to use the square brackets. So I'm going to go ahead and say Alice, perhaps. When you're separating items in an array, you'll separate them via a comma. So then we'll do Bob maybe, and then maybe Charlie. All right, let's go ahead and now print those usernames. We can kind of see what they look like in the console. Cool, so we have Alice, Bob, and Charlie all within the list. Swift arrays can hold any data type as long as all the elements in the array are the same type. So if we were to try to add an integer here, it wouldn't let us because it says, hey, has to be the exact same type of data. In this case, we've created 3 strings. We can use append to add new usernames to the array. So we'll reference our variable here. So we'll say usernames dot append, and this is where we can include that new element. So let's go ahead and add maybe Diana to our array here. And now let's print the usernames once more. And we can see that now we have Alice, Bob, Charlie, and Diana added to our array. We can also remove items. In this case, if we want to remove something, we will do dot remove, and then we actually have to display where we want that to go. We can also do the exact same for adding. So currently when we append something, it's going to add it to the very end. But if we want to remove or add something at a specific spot, we need to specify how to do so. So let's go ahead and say usernames dot remove. And this is where we're going to choose the number positioning. Something to keep in mind is arrays start with the number 0. So Alice would be 0, Bob would be 1, Charlie would be 2, and Diana would be 3. So if we want to go ahead and remove, let's say number 2, so that would be Charlie. Let's go ahead and now print our usernames. And you'll notice that Charlie has been removed because Charlie was number 2. If we want to insert at a specific location, so let's go ahead and use usernames dot insert, say new string element at integer. So let's go ahead and put Eve in, and let's put Eve in at number 1. So let's go ahead and now print the usernames. We'll see in this 4th line of printing here, we have Alice, Eve, Bob, and Diana, because now Eve is being inserted at number 1. So everything kind of shifts around to accommodate that insert. Arrays keep their order, so every item has a specific index. We can even use a for in loop to iterate over our usernames array and print each username. So what I'm going to do is I'm just going to remove some of our extra code here. I'm going to keep the one where we've appended in Diana. So when we append, again, it does go at the very end there. But let's use a for statement. So let's say for username in usernames. And here for our code, we're going to go ahead and print user, and we'll interpolate our usernames. And now we can see we have in order user Alice, user Bob, Charlie, and Diana. We can also use enumerated where we can access both the index and the item, which is really helpful if you need to know the position of each item. So let's go ahead and rewrite this for. We'll say for index, comma, username in usernames dot enumerated. We'll add our brace here and we'll print user. Then we're going to interpolate, so / brackets here, index +1 colon. Then we're going to also interpolate username. So here we're able to assign a number, and we're actually having this be index +1. As I mentioned, it does start at 0. So if we were to remove this +1 here, it would say user 0. That is the actual position in terms of the array. But if you're displaying this to a user, most of the time if you say, Alice is user 0, they're gonna be like, does Alice not exist then? So if we were to use this +1 here, we can kind of see that Alice is the first. This makes a little bit more sense in our brain. I'm just gonna rerun this real quick. Alice is the first, Bob second, Charlie third, right? So by using that enumerated, you can access both the index and the item. So if you need to know the positioning of each item, you totally can. Again, if you want to know if you're making any changes, I wouldn't include that +1 because this is how the array is actually ordered. But I was using that +1, so it's a little bit easier for us to comprehend. All right, and now let's take a quick look at dictionaries. So unlike arrays, dictionaries store key value pairs. So each item is accessed by a unique key instead of an index. So let's go ahead and define a dictionary. So we're going to go ahead and say it's var for variable user scores. And we're going to also declare it with this square bracket here. And we're going to actually say, Alice, and then we're going to add a colon here. And then we're going to be able to assign it with a value. So let's say that Alice has a score of 10. Well, just like in an array, we're going to separate the dictionaries with a comma. We'll say Bob, colon, maybe has a score of 15. And then maybe we'll create an entry for Charlie again. We'll say that they have a score of 8. Let's go ahead and print the user scores. Cool, so this dictionary stores scores for all of the user, where the username is the key and the score is the value. Dictionaries allow for fast lookup by key. We can also update the user scores very easily as well. So if we go ahead and reference the user scores, then within the square brackets, we'll reference one of the items. So in this case, it'd be Alice. We could have this now equal 12. And we can also add, so if we are going to be referencing a user score that doesn't exist, so maybe in this case Diana, we can also add Diana to have a score. So let's go ahead and say user scores, Diana, and let's have their score equal 5, and now we'll print the user scores again. So on the second line here, we can see Bob, Diana, Alice, Charlie, right? And Alice now has an adjusted score of 12, and Diana now exists within that dictionary. Just keep in mind that in a dictionary, keys must be unique. All right, and let's access a specific user score. So we're going to create an if-let statement. So say if-let score equals user scores. Then we're going to reference Bob here. We'll add our brace. We can print Bob's score is, and we can go ahead and interpolate the score value. So we can say Bob's score is 15. So by using the key, we can directly access any user's score. Here we checked for Bob's score using an optional binding to handle cases where the key might not exist. And that optional binding being that if-let statement. All right, let's talk a little bit about sets. So sets are another type of collection. But unlike arrays, they don't store items in a specific order, as well as all items must be unique. So go ahead and create a new variable. We'll call it maybe completed levels. Then to declare a set, we'll say set with a capital S equals, we'll use our square brackets again, 1, just like with the array, you can separate them with a comma. Maybe we'll do 2, 3, and 5. Let's go ahead and print our completed levels. So you can even see when we've printed it, it's just kind of put it in a random order. We have 2, 5, 1, 3, even though up here we've said 1, 2, 3, 5. If we run the program, it'll kind of change the order every single time. It's almost random in what order it kind of prints back to us here. So here the completed levels is a set of integers. Sets automatically remove duplicates and don't guarantee any particular order. So if we were to go ahead and add another 5 and another 3, notice when we run our program, they've removed those duplicates for us. All right, we can use insert and remove within the set. So let's go ahead and say completed levels. Maybe now our user has completed 4. So we'll say dot insert and we'll say 4. We can also remove, so we can say completed levels dot remove. And then for this integer, we can say 2. And let's go ahead and print our updated completed levels. Cool, so now we have 1, 3, 4, and 5. Just remember that the sets don't allow for duplicate items. So if we were to also put completed levels, I think we still have 1 dot insert 1. We wouldn't get that duplicate. Sets also support operations like intersection. So let's go ahead and create some bonus levels. We'll say let bonus levels set with a capital S equals 3, 5, and 7. And we can say let common levels equal completed levels dot intersection bonus levels. And let's go ahead and now print common levels. And let's reference those common levels here. So here we use intersection to find levels that exist in both sets, which can be useful for comparing collections. So we can see that the common levels between the two are 5 and 3. So if we take a look here, 5 and 3, bonus levels 5 and 3. Let's go ahead and also add number 7 here. So I'm going to change this insert 1 to 7. You can see how that's going to update to also now include 3, 5, and 7. All right, let's go ahead and use what we've learned here to build a basic example. We're going to create a function to add usernames to our array, check for duplicates, and list the usernames in order. So first things first, let's go ahead and create our function here. So I'm going to create a function, add username. Okay, and we're going to be requiring a name, which would be a string value. Let's go ahead and create our brace here. We'll say if, we'll add our exclamation point for the opposite, usernames dot contains name, usernames dot append name. So basically we're saying if the username does not, because the exclamation point is opposite, contain the name, then I want you to add this name to the usernames, and then I'd like you to print in the console added name. Just forgot to add my brackets for my interpolation there, to usernames. Let's then create an else statement, which will basically tell the user, hey, actually you already have this within your program. We'll print interpolate name is already in the list. Create some space above our function here. We'll create a variable called user names. Let's have this equal an array. Let's have some names here. Let's do Bob, maybe Dennis, Mac, Charlie, and let's also do maybe Frank. All right, and let's go ahead and now add username, and we'll add a name here. So let's go ahead and add Eve. We can also add a username that's already existing within there. So we'll go ahead and say Bob. And let's go ahead and print the user names. Looks like we are getting an error. It says main actor isolated variable usernames, and in the console it's suggesting that we add at main actor, which is going to basically make this a global function. So let's go ahead and add at main actor. And now we can see that our program does indeed run. So we can see in our print statement here that it says added Eve to usernames. Great. Bob is already in the list, so Bob hasn't been added. And we can see in a function we have Bob, Dennis, Mac, Charlie, Frank, and Eve. So the add username function checks if a username is already in the array. If it's unique, it adds it to the list. Otherwise, it skips the addition, and it lets us know all about that within those print statements. Let's go ahead and now add a sorted list. We're going to sort everything alphabetically. So what we can do is we can say let sorted usernames equals usernames dot sorted. All right, now let's print sorted usernames. Do our interpolation here. We'll say sorted usernames. So now we can see Bob, Charlie, Dennis, Eve, Frank, and Mac. So it's now taken those and sorted them alphabetically. We can even do the count. So we can say let counted usernames equals usernames dot count. And let's go ahead and print that. So we'll print number of usernames is, interpolate that value there. So let's say counted usernames. Number of usernames is 6. There's tons that you can do with this, even if you want to just take a look at the properties. So, have usernames dot, you can kind of see all of the different options. You can even check what these kind of properties are looking for by just clicking on them. So we can even see is empty first, so we can check what that first element of the array is. Totally up to you. All right, that's it for today's lessons on arrays and collections in Swift. We learned how to create and modify arrays, introduce dictionaries and sets, as well as practice adding and managing usernames. Collections are a fundamental part of programming and they'll help you organize data efficiently. Thanks for watching. I hope you enjoyed the tutorial. Please subscribe for any more Swift content. Until next time, dream big, code bigger. Take care.